Hi, I'm Lawrence. Welcome back to the C# workshop. In this video, you're going to learn how to let your applications die gracefully, and that is through exception handling. Exception handling is very important. It's very well known. You need to know how to use it and how not to use it. And we're going to learn about that in this video. So let's get to it. Just like the last video, this video will get you the information that is needed to learn C#. In order to get the most out of these videos, I recommend watching them in their intended order. There will be deep dive videos after the course. All right, we've got our project open for day 15. First thing I'm going to do is get rid of these, disable, denullable, and implicit usings. Again, if you guys want to go and use them, feel free to do it. Everyone that I know that codes in C#, they get rid of these things. I really wish they would disable them as a default. Next thing we're going to do is we're going to go to program. We're going to say, hey, give me my using system up here because that's what I want to see. Going to go up to the project and say add a new class, and the class is going to be worker. And we're going to make worker public. So let's just put a list here of all of the different types of exceptions. And I put the stars on these to show you what are the most used. And by every exception, system exception is the most used. And we'll explain why in a minute. A lot of it has to do with people being lazy, A. And a lot of it has to do with you don't really need to determine what your exception is. You just need to get that information to a log. But if you have user-defined exceptions, which I will cover today, exceptions should be the last thing that is caught. Okay, it always should be the last thing that's caught. So the list that we have up here on the board is system exception, which is the most used, and there's system arithmetic exception, divide by zero, index out of range, null reference, overflow exception, and stack overflow exception. Those are the most popular ones. Anytime you're using one of these, you're still going to use the system exception, and that will make more sense later. We do have user-defined exceptions. They are very rarely used, but if they are used, you want to make sure that you're going to use them correctly. So let's dig into this. And the first thing we're going to make is our trusty execute method with no parameters. And we'll go back over to program, and we're going to create a worker. New, and we're just going to call worker is going to call execute, just like that. Now, one thing I would like to mention at this point before I forget is all of these exceptions inherit from system exception. So if you're using system exception anywhere, any of these can be pushed through that exception. You just got to make sure you catch it. Let me show you something that an exception is. So if we come in here and we say let's just come in and say, let me show you what an exception is first off. And this is just a result of basic division. And you're going to throw in here 50 divided by 0, which everybody knows that knows anything about math. This is not able to be done. All right, so you're going to get a division by constant 0, CS 20. And if you bring this up, it's going to give you a compile error, just like that. So you can't do this because of a compile error. This is the same way an exception works, all right? Just that this was caught in the compiler. So if we come in and we say int A is equal to 50 and int B is equal to 0, and we get rid of this, we're going to take the same kind of deal here, but we're going to say A divided by B. At this point in time, the compiler cannot tell you that this is going to be a failure. You can't pick that up in debugging. So I'm going to execute this with an F5. And you're going to get a system divide by 0 exception, attempted to divide by 0. So that is this exception right here. And that's the first one we're going to deal with. So this is what I would call an application not dying gracefully. All right, you want to have your applications dying gracefully. And anyone who has ever coded with me in the real world will tell you that is my number one thing. Make sure you die gracefully. So how do we go about making this guy die gracefully? Well, the first thing you need to do is you need to learn what an exception is and what the structure is. An exception structure looks like this. You have a try, and there's an area for it, and then there's a catch. Now, you don't have to put anything into the catch if you don't want, okay? And I'm going to show you what happens if you don't. And we'll just take this one step at a time. Hey, looks like everything worked. This is great. Well, it did, but you don't have any information. If I put a breakpoint here and a breakpoint here, and we run, it accepted. This is the exception caught by the debugger. The debugger is telling you. You could say break on this exception was thrown, or you can just continue on. Inside of the catch, you're going to just walk right through, but you don't have any information. You don't have any idea what happened. So you can't tell this to anyone, hey, excuse me, you put in a 0 for your denominator. And I know most people are listening to this and saying, well, you should stop them from doing it on the front end. Well, yeah, it's true, but we're not on the front end. So we can put an exception in here of EX, and this is the standard format. And then we could come in and say console, write line. Now, under an exception, there's a lot of stuff. There's a message, there's the source, the inner exception, because you could have exceptions inside of exceptions. And if we have time during this video, I will get into that. If not, there will be a deep dive on exception handling. So let's run this again. There's the exception. This exception is always going to occur. Now we have the exception, attempted to divide by 0. Well, doesn't that sound like great here, attempted to divide by 0? So if you look at it, more details, you're just going to see this is attempted to divide by 0. So that was thrown, but exception picked it up. All right, and then you can write that out. And if you go back and look at your code, it's going to say attempted to divide by 0. So that kind of puts you in a little question right now. Why did exception pick it up? Well, because like I said in the opening statement here, all of these inherit from exception. So it bubbled itself up to exception. All right, so you can use this. So now if I come in here and say divide by 0, hey, that's going to work, right? And indeed it is. So now you got an exception, and it's going to look exactly like the other one. Pretty neat, huh? Now you could dig down deep enough in here, and you could find, like if you did a type of exception, you could find that this is a system divide by 0 exception. It's not just an exception. But the outcome is the same. So remember what I was talking about. Most people use this. Well, it's because you can. And so why would I want to put this one in here? And remember what I said before, because you're going to want to put this one in too. All right, just to make sure that you caught them both. But for this case, you would definitely catch just one. So why would you want both of these guys in here? We'll get into that next. So the question is why would you want to have 2 catches? Now, this really doesn't make a lot of sense in my eyes, and I don't usually do more than one single catch unless I'm bubbling up. So this here is going to trigger the divide by 0. If I had something else in here, like this, say we drop this up at the top, and this is what this is going to do is this is going to reach out to the position number 4, and we've only got 0, 1, and 2 for positions. So this one will also throw an exception. The problem is if this throws an exception and this is going to throw an exception, the only exception you're going to get is the first one. Now, there's really not much you can do about that with a stack case statement. So you could either separate these into 2 different things, 2 different procedures, and add their exceptions to a list and just return that exception to the back. That's called a transport architecture. So I'm not going to get into all that today, but what I do want you to see is that you may have a decision to make. All right, stacking catch statements is really not that desired. Now, something you can do is you can hit delete here, and you can bubble things up. So if we move those out of this area and move them up to the program, you could put both of these exceptions here. So we could drop these in. You always want to have the exception at the end, but regardless, whichever one happens, then they'll end up being in this, they'll end up bubbling up here and the appropriate one will be caught. It's no different than here, except for this is cleaner, it's easier to understand, and this is easier to control the catch statements. So for instance, let's just run this and I'll show you what I mean. Let me put a break statement here and a break here. Throw this statement up to the top, and now we can execute it. And you'll see in program that we're going to hit index out of range. And the reason that we hit index out of range is because this is no longer a 0. All right, if this was a 0, we would hit divide by 0, but we would not hit the index out of range. It just end the program after that. So these here can be kind of tricky, which is going to bring me into my next conversation that everybody needs to have, and that's try catch statements and exception handling should not be used as conditionals. Hey, if you think there's too much information to remember, then like and subscribe to the channel. Then you'll have a URL that you can go back and look at anytime. If you ever get the idea that try catch is a good thing to use for conditionals, then remember this video, and they are not intended for this purpose, and you'll eventually end up running yourself into a circular reference. I've seen this at 3 companies that I was called in to fix a bug that the development team worked months on the issue and could not figure out what was happening. The code was recursively accepting out, and that means basically there was an exception that was calling another exception that was calling back to the original exception, and things just kind of got out of hand. Once the conditionals were placed in real conditional statements, it was pretty easy to figure out what was happening. So, how do you end up using a conditional for try catches? Well, first thing you need is you need some methods. So I'm just going to do this with generic methods. So there's method 1, and here you want to do something. I'm just going to say 1. We're going to make a method 2. And the funny thing is, I don't know if these companies went to a conference or just had somebody that worked at all 3 companies and got let go. I don't know. So here's conditionals. There's usually a try statement that's been put in with a catch at the end. It doesn't even have to be a catch with an exception. It could just be a catch. And in the catch, you're going to call method 2. There's usually some sort of a calculation or many calculations that are done, like c is equal 550 divided by 5, or it could be some input coming into this method. There's a ton of ways this could happen. And then just out of the blue, someone says, if this is greater than 10, then we're going to call method 1. That, and then else, they're going to throw an exception. And it doesn't matter what kind of exception it is, it just gets thrown. So since this is within the try catch, it calls method 2. And somebody thought this was a good idea. So this is what happens when this here runs. So when c is greater than 10, it's not, so it would call method 1. Otherwise it calls throw exception, which ends up going into method 2, and then you do something for method 2. The problem where this comes out is eventually somebody does the same sort of try catch exception here, and the catch, it could be 1 or 2 or 3 methods below. The catches ended up calling either this method here, like execute again, or it calls into method 1, or it calls into method 2. And you have no idea. And it becomes this recursive circular reference that just keeps on spewing out exceptions left and right, or keeps on doing something that you don't think is going on. This is never okay. If anyone was ever working for me and they did this, I would sit with them and ask them, why would you think this was okay? I mean, it works for very small cases, sort of like microservices. It works for very small experiments, but it doesn't work on a grand scale. But the reason is I've never had anyone at the three companies ever give me a definitive answer of why this was done. The answers I got were, well, that's the way it was when I got here, and from all three companies. So it leads me to believe that there was either one person who worked at all three companies, or a group of people that just went to a conference or something, or read a book, or saw something on the internet, or whatever. This, by far, is not a proper way to do conditionals. This should have never been this could have been a try catch down here. You could have threw a new exception if you wanted to, but this should have been method 2, and that should have been it. And this is an over-exaggerated, simple way that this came about, but it's still, the result was this. The next thing is nesting try catch. This is okay to do if you really have to do it. I don't highly recommend it. And I'm just going to put like a try catch here like that. And nested try catches look a lot like this. Just what you would think. You got a try catch, you got a try catch. Might be a try catch on the outside. This first thing might be for adding a user to your site. And the first thing up here, I'm just going to pseudocode this, is going to be add user login and password. And if that happens, you want to accept out and you want to log this. Okay, so that's pretty much what these catches are going to do. So this is going to log and throw error. But if you do get the person's login and password, maybe you're trying to add address here, and something's just not correct with the address. So you might just want to log this. You don't really want to throw an error. You just want to log it and say, okay, well, we didn't succeed in adding your address. You had a problem with your address or something like that. This might be something for add communications, like phone number, if you don't have your email address, because that's usually your login. These here are not that big of a deal. Okay, so maybe they didn't add any information in the address thing, didn't add a phone number. You're just going to log it. Hey, this person didn't add that. And this could be data used for research later that says most people don't want to put their address in, or they don't want to put their phone number in. I mean, look at websites like Facebook and YouTube and stuff like that. A lot of people don't put that information in, but they got a login and a password and they can use it just fine. So one thing that I want to mention here is since we're still talking about tries and catches, is the ability to put a finally in. So after you have completed your try catch, you can put a finally in. This code would run 100% of the time. If the try works, it's going to skip the catches, it's going to run finally. If the try doesn't work, it hits the catches, it's going to run the finally. So here at the finally, a lot of people today, they might log completed. Like this might say log, address completed. And you might have another one down here to log communication completed. This assists with debugging issues in your code. These used to be used before using statements got better to open up a file, do whatever you needed to it. If there was a catch, you could log it, and then finally you would close the file. That's not really done that often today, and these are, I barely see these when I'm out on a job. So it's something just to keep in mind. So this is where nested stuff comes in. It's not bad, but if it was me, I would have this in its own method, and I would have this in its own method. This way, there's no chance of having somebody misunderstand what you're doing. Okay. So if we were to create like a missing name exception, and this is just something that I'm just kind of winging at the moment, but you type in public and then override, and you can see all of your things. Like up here at the top, you have data. This gets a collection of key pairs to provide additional user information about the exception. You have a help link you can put in. Most people just override message, but I'm not saying that's the only thing you should be doing. And this would give back the base message. But you could put something in here like, I'm assuming this is going to be used for somebody's name, like if you're creating a person object. And you could say something like, you are missing first name or last name. And that could be it. Simple as that, nothing major. You could add more information to it if you wanted to, but if we create a person object, which I have right here, and here's first name, last name, and say inside of person we have a something like this. These guys could be private. It doesn't really matter. This is just an example. And you can put a void here, and you could say create, and take a string of first name and a string of last name, like that. So say if the string is null or white space for the first name, or the string is null or white space for the last name, then you want to throw a new missing name exception, and that would be it. Else, you could set first name equal to first name, and last name equal to last name. And since these guys are private, they should probably be lowercase, and we put this in front of them, like that. And the way that this would work is we would create a person. It's equal to new, and you could call person.create. And let's just put Lars in there, and then there is no last name, or it could be null, or it could be a bunch of blank spaces, it could be anything. So if we run this, so these are, and they're going to throw an exception. You're going to get missing name exception, you're missing first or last name. If you look at the whole thing, that's it. And that is pretty much all there is to making your own exceptions. So now if you think about this and you go back to here, where we did, a division of this A and B, the only thing that happened is someplace somebody got code for that slash, and they checked to see if that slash was equal to 0. If it is, then they threw the exception for division by 0. Okay, that's really all there is to creating your own exceptions. Now, why would you want to use these? Again, if you're doing something that has a bunch of errors in it, like here, you might want to throw an exception for the address or throw an exception for the communication. And if you're up in the program area where maybe you're doing a throw at the end here and you're catching all these things, maybe you have something up here that says catching a missing name exception or an address exception or a communication exception, and you want to throw that specifically for the user. Now, I work a lot in what's called a multi-tiered environment, where we have a front end call its back end through services, and then that services calls into another set of back end services to talk to the database. And we might even go to another layer to actually talk to the database. Depends on how the systems are set up. You might just have something in the middle that is more like an orchestration, or there might be something in the middle that is deciding which database to go to. So it's not actually orchestrating call location A, call location B, location C. It might be call A or B or C. So those are things that you got to kind of think about. If this was in a service, it would never go to the front end. All right, so you'd have to accept up to this layer, which would be the service door, and then send something back to the front end. So typically bubbling stuff up to another layer is not used that often, at least not to send stuff back to the front end. So the last thing I would like to talk about, which really kind of mixes in with exception handling, but it more mixes in with conditionals. And I needed to get past generics and some other things before we could talk about these. And these are called ternary operators. A lot of people call these inline conditionals. I don't care really what we call them. The best way to explain what a ternary operator does without getting into a bunch of confusion is actually, let's add a address class. Now, an address class just has the basic stuff in it. So I'm just going to drop these in. We can take these very easily. And if you wanted to come over to this ternary, you wanted to say address is equal to new. Let's just put in some fields here, just a set of generic fields. And then at the end of this, we need to put a semicolon like that. Scoot this over. So now we have an address. And let's put a street 2 here. Street 2 is equal to apartment 1. There we go. Okay, so now we want to get this address displayed out. So we're going to say console.writeLine address dot, and we're going to put a display method in there. So let's go back to address, and we're going to put a public string return and the standard for display, and we're going to say return, put an enter, going to put a little $sign in front of that, and then we're going to drop in a structure for the street 2, city, state. But say you just want to have this like this. Now, and a semicolon. And if we ran this, this would look pretty good. There you go. 123 Main, apartment 1, a city, Ohio, 1235 USA. And it looks pretty good. And I'm saying it looks pretty good because we're going to change it. Because what if somebody comes along, and I'm going to create another address here, and we're just going to take out street 2. They don't have a street 2. They live in a house. They don't live in an apartment. They don't live in anything, where you would need a second line of your street. Some of these have thirds, fourths, or fifths. And if we were to run this, they're going to look different. Okay, yeah, I know I'll put a breakpoint, a right line in between these, but 123 Main, apartment, 123 Main, blank. This is a little different to read. So we're going to put in between these guys like that so you can see them better. So what if we create a display 2? And you'd have to come in here and say, let's just get rid of this, call this display 2. And that would work. Right? So it looks pretty good. The problem is now the people outside of your application have got to have something here that says, if street 2 is there, call display. If street 2 is not there, call display 2. So we don't want that being outside. We want that to be inside. So let's adjust this. So what if we put something like this in? And we said street 1. All right, so let's just put this down here. So if we put this like this, this would work, right? Street 2 is not there, but if it is there, at least it will produce, okay? All right, so we don't want the blank space, and we don't want, this to be all smushed up, but we'd rather have it all smushed up without the blank space. So what we're looking for is this or this, and these two be mixed. All right, so let's look at display and think outside of the box a little bit. If you could take street 2 and put it up at this level, and if you could take, and if street 2 was not null, if you could put a carriage return line feed in with street 2, and if it was null, you could put a blank in, that would take care of our problems. So let's take street 2 and set it equal to, just like we said, if string is not null or white space for street 2, put a question mark, and then you're going to return \r\n, the $sign here, with street 2, and if it is null, you're going to return a blank. And that looks pretty good. So let's go back to worker. Going to run these both on display and see what they come out with. So we got our 123 apartment 1, a city, and we got the 123 with no space and no apartment 1 sending off to the side or any place. So that's what we're looking for. Notice they're both calling display, so I can get rid of display 2. Now, would it be nice to be able to put this here inside of here, right? You'd think you could just drop it in. Let's throw in a whole bunch of errors. A way around this is to put a parenthesis on this side and put a parenthesis on this side. Now, just like a math problem, you've encapsulated that code to run, and then the outcome of that will appear. If we run this, it'll work just like it did when we were assigning street 2 outside of the return statement, just like that. That is a ternary operator. Now, thanks for watching the video. Please like and subscribe to the channel. I really hope you enjoyed the video, and I hope you now understand more about exception handling. The only true way to really learn and understand about exception handling is to play with it. Just like every other topic that we've talked about in these video series, unless you work with them coding wise, you're not going to really learn what they know. You're not going to really learn what they are. You may be able to talk about them, but there's a whole thing about talking the talk and walking the walk. And if you can't walk the walk, you're not going to make it in programming, like ever. I'd really like to wish you good luck on the rest of your journey. I hope you come back to the channel and find other deep dives and stuff that might help you out later. If you have any topics that you want me to get into or get deeper into, drop a note in the comments, send me an email. Remember to like and subscribe to the channel. Click that little bell to get alerts when the new deep dives come out. I'm going to try to get them out about once a week. And you're always welcome here at the C# Workshop, and have a nice day.